Hey everybody, welcome back. This is Dawn Zoldi, your host of the Dawn of Drones podcast. So great to see you. I can't believe it's 2022 and we're almost halfway through it already. And we are focusing this year and this month in particular on Tech Showcase. We kicked off the year spectacularly in Las Vegas with our month sponsor, Dragonfly, and Cameron Shell, the CEO. By the way, fun fact, we broke all kinds of records with that podcast last week. So we are on a roll. And we have with us today an incredible person and from an incredible company, Savanna Horan from Fenix Group out of Chantilly, Virginia. Welcome, Savanna, to the podcast.
Thank you. It's really awesome to be here, and thank you so much for having me. I got to see Cam's Cam Shell on last week, so hopefully I can do as good as he did.
Well, I'm sure you will. I'll tell you, like he absolutely is a tough act to follow, but I know you're up to task. So everybody, I met Savannah at AUVSI Exponential last year in August in Atlanta, Georgia, and we went out for a coffee and just got to talking. And I was like, man, what you do is so cool. You have to be on my podcast. So Savannah is what they call a senior robotics engineer. And, Savannah, I want to start there because we had a great discussion last week on Clubhouse. By the way, everybody, if you're not on Clubhouse, you should be. If you're not in the Drone Law Connections room, you should be. All of these discussions are available for playback on Clubhouse. But we started out that discussion, Savannah, talking about you and your background and this idea of robotics engineering, which I learned something new. I did not appreciate like the complexity of that discipline. So let's start there. Can you tell us a little bit about what robotics engineering even is?
Sure. So it's always fun to get into because there's so much that goes into it, and there's so many different things that it incorporates in. Because when you think of a robot, and we can think of like even a little turtle bot or a Roomba, there's everything, every type of engineering goes into that. So you have electrical, obviously the big guys, the electrical, the mechanical, and the software. But I know one of the things we brought up last week was also space, air, underwater. So you're bringing in aerospace, aeronautical, physics, communications, of course, networking. Every single aspect of engineering can go into robotics. And I've typically worked in underwater, air, and ground. So I've been able to play with a lot of different types. And with robotics engineering, when I came out with my degree, their industry typically puts us in two categories, either programming, because everybody needs programming, or systems engineering style, because we really have to think about how all these systems work together and how the robot is as its own little microcosm. And now as the industry advances, how everything works together. So even
Yeah,
other
it's
robots.
yeah, we talked about this. It's all about networking, and your path was so interesting. So your college that you went to was WPI Worcester. Did I say that right? Uh,
Wista.
okay, I'm not from Massachusetts. I'm from Philly, so it's Worcester. Polytechnic Institute, WPI,
Yep.
and that's in Mass. And you got this really cool internship right out of there. In fact, you were working. You mentioned the Roomba, that
Yep.
vacuum robot. You were working on that when you got your first job. Is that right?
Yep. So iRobot, which is the company that makes the Roomba, they are based out of Bedford, which is not that far from Worcester, and it's on the outskirts of Boston. And I ended up getting an internship there, and then was able to start working with them. And I worked on the Series 980, which was the first one to have the cell phone app. So I got to help with that, with the languages. I got to help with the navigation because it came up before in the older ones, they used a random bump navigation. So it would bump into the wall and then it would spin around and randomly pick something. So to make it a bit more neat looking, and to help advance the system, we wanted to do more of a lawnmower, because I don't like cleaning that much, but I still like to see those little lines in the carpet. So
Oh, great point. So almost like the back and forth to have the
yep.
straight lines. No, that makes a lot of sense. Honestly, you don't work there anymore, but I got one of the original ones, and my biggest frustration was not only the bumping randomly or stuck under specific pieces of furniture and having to unjam that, it was the very small receptacle. It's
Mhm.
just like, okay, I've got two dogs, and that thing's going to fill up in 2 seconds. So, having a bigger thing. But from there, you did a stint with the United States Navy because, you just mentioned some
Yes.
underwater vehicles. So tell us just briefly about that because that's super cool.
Sure. So I grew up on the water, absolutely love the water, and the idea of underwater robotics and all the complications that they have has always been fascinating to me. So the Navy and I, and this particular base I went to, learned of each other while I was in grad school, but weren't able to make it happen initially until afterwards. And then they came knocking and said, "Hey, we have underwater robots you can play with." And I'm like, "I'm good. I'm out."
Yeah.
So I
Yeah.
went and I got to play with those and really work on the navigation and the coding, and get exposed to the difficulties with underwater robots, and how important communications is, because it's funny that at one AUVSI I went to, the Air Force was talking about the difficulty of autonomy and trust. And obviously they have a bit more interesting problem because they're flying above people, while underwater, if it goes down, it's just going to combust. But the Navy, because they haven't been able to have the communications like the Air Force has, had to come up with a trust system and a better, or not a better, but a more complete and trustworthy autonomous drive from the very beginning. So
Yeah.
it was interesting.
Well, and just the medium, right? Water. I
Mhm.
learned a little bit about this because one of the first articles I did actually for Inside Unmanned Systems magazine, where I'm a columnist, was about unmanned or uncrewed underwater vehicles, and just learning about the need for sonar or having to tether them for these very reasons. The communication from the ship to that UUV, very difficult, especially the deeper you go and the farther out you go, obviously. So really, really cool stuff. I mean, really incredible background. And then at some point you landed at the Fenix Group. So tell us about that journey and tell us a little bit about your current company.
Sure. So what brought me actually to the area where I was able to learn about the Phoenix Group was the Navy again. I ended up working for NavAir this time in their machine learning lab down in Maryland. And then I learned about Phoenix, and I was very intrigued by their use case and their problem set, because as a roboticist, I had always been using Wi-Fi to communicate with my robots. It was, when you're dealing with underwater, you're just, like you said, you're just kind of sending it off and hoping it comes back. So you don't have to worry as much about communication. And so most of the stuff was in lab testing, where we always had Wi-Fi and we always relied on that. When I learned about the Phoenix Group and how they were utilizing cellular communications on how to communicate not only between people, but also bringing in IoT sensors and robotics, and how do you get communication between the robotics and the human for kind of that human machine teaming that everybody's kind of pushing for, is it shocked me. I was like, oh, this can happen. I always thought cellular communications was this big unknown that Verizon and AT&T just do.
Right,
But
right.
yeah, with Phoenix Group, we have like a backpack version that doesn't have to be connected to any sort of tower at all. It's its own cellular comms that is completely transportable, completely mobile, and completely self-contained. So you can have your communication system for your robots, for your IoT, for your people right there. And that was really exciting to me. So I met them and I ended up joining, and now I have my robotics lab and I'm pursuing making that really push forward with more and more robots and more sensors to get that kind of mobile perimeter. And like what was mentioned, I think in the pre-thing to this Merlin, so the Mobile Robotic LTE Network.
Right, right. Yeah. Well, I want to dig deep into all of that. But first, I want to kind of back up for a second, just so people really appreciate that maybe aren't savvy about the difference between kind of Wi-Fi and cellular and some of the limiting factors from a communication standpoint with, right, with one or the other. Because you're talking about having a transportable backpack version that could be separate from that. And, I'm trying to get at, why the need, in other words. So let's talk first Wi-Fi, right? Like, so I don't have my phone here. I actually turned it off and take it out of the room. But everybody thinks about Wi-Fi. They know they turn the phone off. They just have it, or they have LTE. LTE pops up. We're selling it. I mean, what does that even mean? Like, what are we picking up? We're picking up things in the RF spectrum, sometimes from towers that are local, sometimes not.
Yeah. So how the infrastructure, especially in the US, Europe, is kind of set up is you have all these cell towers and you'll have little repeaters. And I know probably some people have gone driving down highways and they see these weird looking palm trees or pine trees where
Yeah, they
people are,
don't look very, I mean, they try, but it's like, okay,
they
that is
try.
basically a stick Christmas tree. We know that's a tower. Yeah.
Yeah, where you see all these panels sticking out. It's like, I
Yeah.
don't think that's a nest.
Yeah.
So they have all of those infrastructure set up. And typically what you're doing is as you move, your cell phone is looking for the strongest signal with your provider. So that's why sometimes you'll go some places and somebody with AT&T will have better reception than somebody with Verizon, or somebody with Sprint, or somebody with T-Mobile, whoever.
Sure.
It just depends on what their setup is in that location. So you'll have the cellular networks set up infrastructure wise. And so as you're moving, your cell phone's just looking for the strongest signal to give you the most data, or the most
Wicked.
signal.
And it pretty much autonomously does that. I mean, I think
Mhm.
we kind of take it for granted until it doesn't work, right? Then you're just
Yes.
like, I hate my plan, or, oh, this isn't working. But so it's something I think we use every day. And now,
Mhm.
we're going, 4G, we hear fifth generation or 5G and that coming online. We can talk about that later. But
Mhm.
so the need for your product, Merlin, this kind of transportable, self-contained, I'll call it, communications control network, if you will, C2.
Mhm.
When those towers go down or don't work, people need to communicate, right? I mean, so
Yes.
when I think about the use cases for this technology, clearly battlefield applications, and I've looked at your, the Fenix Group's website. Clearly you have a huge DoD line of effort. So let's talk first about that, and let's talk
Okay.
about these C2 comms on the battlefield, and how Merlin is contributing to that.
Okay. So the backpack version is our Banshee tactical radio. It's our BTR, and that is about I want to say 17 pounds. It has hot swappable batteries, so you're always able to keep going with that. Two bands, two bands that can be utilized, and then a mesh radio that you can have multiple backpacks that would mesh. But this particular thing can handle up to 256 end users. So that means either, let's say you have 10 people and each one of them has a cell phone and they need to talk to each other. So 10
Right.
cell phones, that leaves you 246 open potential use end users. So the idea with Merlin is to really take kind of the phrase for Phoenix, the battlefield of things infrastructure, and push that further, because robots are a useful tool. They're an advanced tool, and we're still finding the best place for them. But there's three things that robots are really good at: dirty, dull, and dangerous.
Yep.
So for that idea, especially on the battlefield, not only can you increase your situational awareness by putting this line of mobile robots further, you
Right.
can also have a perimeter, almost like a guard perimeter. Because if one of your robots goes down,
Right.
now you're thinking, okay, wait a minute. But robots are also, they're attritable. Yeah,
Yes. Yeah.
as
Yeah.
much
We
as every,
send the robot in instead
yeah,
of the soldier, sailor, airman, marine, guardian,
yeah.
because they're expendable, right? And if we lose the robot, that's unfortunate, but it's much easier, right, to replace that robot than a human being that, that we've first of all value their lives, and obviously we've invested a ton
Hmm.
of money training and developing as leaders and as soldiers, sailors, airmen, marines. So let's back up for a second, just so I'm clear. We're talking about the tactical radio,
Yep.
okay, and then Merlin. Is Merlin essentially the backbone for the radio, and the radio is a means of communication? Am I saying that correctly?
Merlin is the ecosystem.
It's the ecosystem, okay.
Yeah.
And the
So it's
radio is a piece of that?
the radio is the backbone of Merlin.
Oh, okay, I had it backwards. Okay.
Hmm.
The radio is the backbone of Merlin. Merlin is the ecosystem. And as we described it, you explained it on Clubhouse, which I love this analogy because I'm kind of a visual person.
Hmm.
You said it's almost like a hub and spoke.
Yep.
And when you discussed mesh, you said, imagine a wagon wheel, and the exterior of that wheel that connects all of those spokes on the outside is your mesh net, so that if one of those spokes pops off the hub for some reason, it goes
Hmm.
down, it's still connected on the outside to all of those other, let's say radios or whatever, or robots, and still has that connectivity. Did I kind of explain that right, the way you've kind of characterized this?
Yes. So the what I think of as the hub is
Yeah,
actually the radio.
got it.
That's
Okay.
the BTR, the BMR, which is our Banshee Mobile, which is just a larger version. But the BTR, the radio, is the hub.
Okay.
And just like a tower in a cell phone, in an infrastructure, cell phone infrastructure, the radio sends out all the lines to all
Yes.
the users. So you could think
You
of the
also might have
users.
radios.
They might have radios. They could also have the what we were talking about. Our new product line that's coming out later this year is called the Talon Puck, and that will be a mesh style radio that can hook in to cell phones or another device that you have. So I've used something that won't be as once our robots are, or once the Talon Puck is in production, then I'll start implementing this on the robots. I've used another kind of bridging things to work through it, but that's the mesh aspect. So if you think of the user
Yep.
in the wagon wheel description, the user is where the wheel and the spoke meet at that point. That's
Okay.
where the user is, and the hub is the radio. So if, like you said, if the user loses connection to the radio for whatever reason, but is still they're still able, and they have this mesh aspect, they're still able to communicate to the other people that are physically or as long as you're not breaking physics, that are close enough to them to communicate, and then that information can just be passed down.
I laugh because it's like I'm not going into physics with you because I can barely get the hub and spoke analogy down, without getting into the laws of physics. But okay, so on the battlefield, I could see where, and not to put too fine a point on this, but when we talk about backbones in general, like communication is the backbone to any operation. I don't care whether you're on the battlefield doing disaster management, public safety, critical infrastructure, or just a commercial application. It doesn't matter. You always need that C2. And what I love about what you've done with Merlin, fun name, by the way, an acronym, is you've created a mobile network that is independent of these other large carriers that, in the event of an emergency in particular, or some other disaster, like, you can still operate. And that is so, I can't even describe like how significant that is. So you and I had talked about, Savanna, like, looking back in time, we just, commemorated in September the 20th anniversary of 9/11, horrific event. I wasn't in DC at the time. I was actually at the United States Air Force Academy. I think everybody can remember the day, if they were in the United States, maybe even globally, like what they were doing at that moment when on TV all of a sudden they see planes crashing into the Twin Towers and the Pentagon, and then a field in Pennsylvania. But I had friends that were there in the DC area, and communication was a huge issue. Because it wasn't like the towers went down, they weren't attacked, but they were overused and overburdened, and so you just could not get through. So superimposing your technology, if you could go back in time and you were working, let's just say, with the Arlington PD around the Pentagon as an example, how would Merlin, how would your your Talon tactical radios be deployed in that scenario?
So in that scenario with, let's say you had a group of even 50, let's just say you have 50 PD moving in to wherever they need to go. One person has a backpack. Everybody else has cell phones. Everybody else
Wow.
is connected. And that group moves. Now you're going to have, of course, because of the gravity of the event,
Yeah.
everybody was mobilized.
Yeah.
So you have that group with that radio, and that radio also has an integrated mesh radio that allows it to piggyback to another one. So you have another group of 50 that has one backpack. So you have 50 with one backpack, another group of 50 with one backpack. Those backpacks are talking to each other, and they can be communicating back to headquarters, or the talk wherever the command center is set up.
Yeah.
And so they have 100% situational awareness of what's going on, even if people are just texting back to each other, or if somebody gets on the horn and is just saying, okay, we got this in this area, we need more people here. Everybody's going to know about that.
Yeah.
That is what this system is meant to do, is increase situational awareness for everyone to make quicker decisions and to be more aware of what's going on.
So we didn't talk about this before, but having spent 28 years total almost in the military, in one capacity or another, people are very squeamish about communications on open networks, right? Because especially when you're talking about tactics, techniques, procedures, TTPs, with law enforcement or military types, are these C2 lines or communication, your mesh, is it encrypted? How is it cyber secure, I guess, is my question.
Yeah, that's a very good question. We have done many different things with the system. We have been red teamed multiple times, and it has not been successful. So, and for anybody,
Meaning the red team did not penetrate. So for those
yeah,
out there who don't know what a red team is, I mean, we're talking the same language here, but
yeah,
people without a military background that may watch this may not know, especially we have a lot of drone folks, and we're gonna talk about commercial drone applications here momentarily. That's when you have a group out there, they're out there, but they play the bad guys, right? They wear the red hat and they try to attack your system. And in this case, it sounds like they were unsuccessful in trying to penetrate your network.
yeah. We have. So the good thing about a self-contained network is you can do many layers. We have also been able to. I mentioned last time that we have basically an RJ45 Ethernet port where you can connect into any sort of backhaul that you want. So one of the things that we've been able to connect with is we've been able to connect with encryption boxes, to translate data that might be a lower encryption to a higher side encryption.
Got it.
So
Yeah.
we've been able to do that. We also cut our own SIMs and program our own SIM cards, so we can control the phones and what phones are allowed on, what phones are not allowed on. So we can do a whitelist and a blacklist. And we even within the cell phones, we have a program, a software app that will keep, if the phone is being interrogated, will alert you and shut it into airplane mode immediately, or will make sure that you cannot endanger yourself. So you're not going to
Wow.
be downloading Instagram on
Yeah,
it.
yeah. Yeah, we don't want to be doing that.
Yeah.
So we're talking about a lot of different buzzwords. We talked about IoT or Internet of Things. We're
Mhm.
talking about mesh networks. Um, Reading your website, it also talks about basically I just lost the word. It's a edge computing.
Yes.
Okay, so this is another term that people hear about but may not know what it means. How does edge computing, what is it, and how does it factor into Merlin and what you all are doing?
Sure. So what edge computing is, in just its general breakdown, is it's taking computation that used to have to be, so a lot of the sensors used to just be dumb sensors. They're there,
Okay.
they're doing like ultrasonics, pinging, pinging, getting pinging back. Okay, cool.
Gotcha.
Everybody has seen them, like Red October, where you see a little ping, ping. That
Yeah.
they used to send all the information back to be processed.
Got
So
it.
what that does is that adds time. What edge computing is doing is cutting that time. It's giving the computers, attaching the computers to the sensor, integrating it with the sensor, allowing certain things to be done at the sensor level where it is. So this is a really good example I like to use for this is perimeters. This goes into the dull of the dirty, dull, and dangerous. Is humans
Right.
are notoriously bad at staring and reviewing things for hours and hours and hours.
Right, right.
So what you can do is, let's say you have a visual camera that's watching an area of fence, and
Okay,
it
gotcha.
knows what the fence is supposed to look like. So you add a little computer, you add a little object recognition algorithm, and it knows what the fence is supposed to look like, and will never alert unless something is different, something is wrong. And
Okay.
then, like, let's say the fence gets cut, or you have the fence here, and all of a sudden you see an animal or a human or something going through. That's
Yeah,
obviously not supposed to happen.
right.
So then it can take that information and send it back and alert a human, where a human can take over and do what they do best, which is unique situations, reacting in unique situations.
Okay, so it's like smart sensors and then kind of these alerts all with edge computing, like the sensors are smart, basically. Okay,
Yeah.
I get it now. So, wow. So you just talked about perimeter security. I mean, we basically gave a disaster response,
Hmm.
terrorist response example with the 9/11 example. So many other public safety examples we could walk through.
Yeah.
Let's transition for a second because we have a pretty, I think, pretty decent commercial drone crowd that follows
Okay.
this podcast. It's aligned with DroneLife that focuses quite a bit on the commercial drone industry. Of course, other applications like military, but um, drones are robots, essentially,
Yes.
correct? Excuse me. Over under on whether I have COVID. It said no yesterday, but we'll see. From CES last week, I'm not feeling awesome. So how and we're talking in the commercial drone industry about the holy grail beyond visual line of sight,
Hmm.
having that communication with the drone, not only to detect and avoid and those alerts that will go back to the ground, pilot on the ground. um, how would Merlin and these radios play in the commercial drone industry? What is that crossover that you foresee for that industry in particular?
For that industry, there's a lot of interesting ways that things can be done. So typically, when you have a drone, you have one person, and that one person is controlling the drone. That one person is seeing what the drone sees, and that's it. So for the ground side, what you could do is you could have one of these radios, one of these Banshee radios,
Right.
and that can send the information that that one person is seeing to everybody on the system. So they will all see what that drone sees. And let's say you have 4 people controlling drones.
Or how about, let's flip it. How about one person controlling many drones? Because that's the vision.
Yeah, I love that vision. I just want us to get there. Anytime it's robotic teaming and human teaming, I'm all for it. So yeah, if you have one person that's controlling the group, and the group is sending so we'll combine the edge computing. They're going to be digesting what they see, and they're going to be like, oh, well, here's an alert, or here's an alert. Alert came from drone 5. Alert came from drone 7. Where are they on the map? All this computing thing is happening, but all that information, if it's on our network, is being proliferated out to everybody that's on the network. So you can have, if somebody wants to see like, okay, drone 5 alerted, why did they alert? Then it can be set up where they could look and isolate drone 5 and look at like, okay, what are they doing? Make a decision, move forward. So that drone controller only has to worry about controlling. Doesn't have to be a sensor person. Doesn't have to be able to say, okay, group, do what I hope you can do while I try to figure out why this one is saying what it's saying. So more people you can have one person doing multiple drones, but then you don't have to, that person can just focus on those drones and making sure that they are flying as they want, and you can share the information back. For the air side, you can do relays. So if you have drones? Yeah, you can do relays between the drones. If they have like the mesh radio set up, you can hook into our mesh. We've done that before. We've also relayed between groups on the ground. So you can't really project signal through a mountain, but if you have a drone or a couple drones up ahead, then those 2 groups that might be on either side of a mountain can talk to each other.
Oh my gosh, that is so unbelievable. And so in the commercial, let's stick with commercial, and my brain goes to, the Hindu Kush, or, when you say things like, oh, we can communicate over the mountain. But getting back to this kind of commercial idea. So your network can be used to relay information, control the drone, relay data from the drone that it is picking up, that imagery, whatever it's doing, back to a command center or to other people, and also relay communications between each other and amongst each other.
Yeah, each one would be a slightly different setup, a slightly different configuration, but those are all things that we've done before. That's one of the beauties of that little RJ45 port, is I've gone into people and they're like, well, here's our system, and I've taken an Ethernet and go, boop. All right, now everybody sees what you're seeing.
Wow. So like for precision agriculture, as an example, you could have a fleet of drones controlled by one person remotely, that, let's say hypothetically, is not only analyzing, maybe the moisture level of the soil and where maybe watering is needed on a very large crop, but then also a fleet that would then do that precision spraying, as an example, using your network, and they could all talk to each other. This is like crazy. I mean, that's unbelievable. So let me ask you this, like you mentioned, like batteries in a backpack and swapping it out. Going back to that example, pucks, how long, like if, let's just say, I'm in Miami, the horrific building collapse that occurred. I've got my series of drones, my fleet of drones that I'm going to be using to try to help find survivors, and things like this, maybe using dragonflies, biometrics, like where are the most, injured groups, and, where do I need to send my assets? How long in that portable scenario, how long do those batteries last? How many times? Because, I'm just a recreational pilot. I haven't flown a ton. It is a goal of mine to get more official this year, if I could find the time. But I hear from all my friends that are pilots, it's the battery life, like, that's always an issue. And if it's cold, it's like, just with your iPhone or your Tesla, it's like the battery gets sucked. So how does this work?
So it has the backpack will last with the batteries about 6 to 8 hours. The cool thing is it will actually last however long you want to carry the batteries, because the
Yeah.
batteries are hot swappable.
Okay.
So there's two in on the bottom, and
Okay.
you can pull one and put a fresh one in, and then pull the other and put a fresh one in, and you won't lose connection.
Wow. Okay. But how long on one? Is there like kind of a, generally speaking, if say I forget, I'm not a good soldier and I left my swappable batteries at home. How much juice do I have for how long?
That's 6 to 8 hours.
All right, well that's pretty significant
Hmm.
regardless. Okay. We had a couple pings in the audience. I do want to acknowledge that. We've got let's see, Before You Go is saying howdy. Before You Go is kind of a dedicated fan and always jumps in here. We also have Dan Julin from Canada coming at us. He's saying hello. The relay aspect is very interesting to me. I would love a conversation about it. So, Savannah, I will hook you up with Dan after this. Dan is now working for a group called Arium, AERIUM Analytics, up in Canada, and yeah. So I'll definitely link you two up when we're all done here. But that's exciting, and frankly, so many other people when they hear about this are going to be excited about it. I've already offline linked Savannah up with a couple folks that I know are in disaster management or have a public safety emphasis, that are going to want to use this, let's call it battle tested, battle proven technology. So pretty unbelievable. You mentioned this puck and the idea that it's going to be maybe like a smaller relay
Yes.
that can be placed onto a robot, like a drone or a ground vehicle. Um, so when do you think this technology will be released? Is that something happening this year in 2022?
Yeah, that will be in 2022. It'll be in the later half of the year. We're aiming for around the third quarter.
Okay, awesome. And no, I mean, look, you don't want to, you always want to you want to under promise, over deliver. So if it comes out
Yep.
before that, it'll be like, wow, they're ahead of time. So quarter three is probably a good, safe bet. Um, we talked on Clubhouse also. Think about disaster management, disaster response, resiliency, and the military. We've got this incredible group of people called the United States National Guard. And for those that aren't super familiar with the Guard, you probably are in some capacity, because I almost guarantee if you live in the United States at one time or another, you've run into a National Guard unit that was deployed either in a state status, which is why they're so unique, working for the governor, or in a federalized status, working for the DoD under Title 10, that was doing something, whether they were giving out water in a disaster, or right now, I believe the Ohio governor has activated its National Guard forces in hospitals to assist because of the manpower shortage in hospitals due to COVID-19. Just a couple examples, but uh, fun civics lesson, everybody. When you think about disaster response or terrorist response, everybody thinks about the military, but honestly, under the 10th Amendment, the states have that authority and responsibility to protect the welfare of their citizens. And so that National Guard, those National Guard units are really, besides our, of course, law enforcement and other public safety EMS folks, are always going to be our first line of defense. And when I think about your technology and everything that's been happening in this country over the last couple years, wildland firefighting in particular, look, last year the United States was on fire. I mean, heck, we literally had Boulder, Colorado on fire in December, and 1,000 homes were lost. That's insane.
Yeah.
Um, I understand you all are working with the National Guard, or maybe just have forged a new alliance. Can you tell us a little bit about that? Because that's really exciting.
Sure. So we're working with DIU, which my understanding is Defense
The
and
Defense Innovation Unit. Yeah, they do the
yes.
blue. The commercial drone crowd knows all about them because they do the blue SUAS program, the blue UAS
Ah,
program.
okay.
So the cyber secure, frankly, non-China related component drones that have been approved for a GSA list for purchase by the feds
Okay.
and sometimes for people that are getting federal grants. So people, I think, in our community, in our circle, are very aware of DIU. So through
Good.
DIU, you guys
We
are doing
are,
what?
yeah, we are outfitting the California National Guard with
Wow.
some of our systems to help specifically for the wildfires and or landslides, mudslides, what earthquakes, anything that can interrupt, destroy comms, or where there's a need for a comms system to be mobile, to be deployable, and to be readily available. So that's what we are going for right now.
Well, that is a perfect fit. And I hope at some point you guys come out to Colorado where I am because, when I think about the states in particular that are struggling with, well, I mean, it's the whole country, but, California tops that list clearly. And then Colorado, I think is, I don't want to say close second, but, yeah, I hope we get out here and then we get to work together because I would love to, yeah, see you in person again. And so let me ask you, am I going to see you at AUVSI again this year in Orlando in April?
Yes, you will. I am very excited because I actually got a presentation spot at
Yay.
AUVSI Exponential this year where I will be talking about Merlin specifically since it's a robotics heavy group. And
Yeah.
I am very interested as well because last year there was a huge public safety sector that I
Yes.
kept going to their meetings and listening in. And so I'm looking forward to getting more information out and hopefully getting more partnerships and really pushing this technology to be as useful as possible.
Well, it makes a lot of sense. And the group you're talking about there, Savanna, is drone responders. Charles Werner and Christopher Todd with the Airborne Incident Response Team. Of course, you've got the Cajun Navy as well that does, but AIRT, they're the ones that do the air response in disasters, the volunteer group.
Mhm.
So incredible people. I'm so looking forward to seeing you there again. So everybody, this is the first time you're hearing this. This is my big public announcement coming out. We are going to be doing our first ever Law Tech Connect workshop in conjunction with AUVSI on Monday, April 25th. A full day of incredible panels from 8 to 5. All meals will be included. That registration should go live here shortly, but we hope that you make your plans and come a little bit early. So, when people are setting up their booths, that's what normally happens on Monday. You
Mhm.
can come to our incredible event all about law and policy. And for the attorneys that are out there, this is super exciting. We actually got 8 continuing legal education or CLE credits from the Bar of Florida, 7 general and 1 substance abuse. There's going to be a book involved and there's going to be a VIP reception. It's going to be amazing. So please join us. And we are getting super close to the end of our time, Savanna. I'm looking forward to seeing you again in person. But before I do that, and before we close, I'm going to give you the floor for your 30-second elevator speech. Whatever we didn't cover that you want to make sure you leave people with before we close out this particular episode.
Sure thing. So just really quick, love the public safety sector, love disaster response. This is a really cool technology. So if you have any interest in that, please reach out to us. You can find us a quick Google search. Phoenix is spelled Fenix. And I really want to see this human machine teaming, and using this communication backbone is phenomenal, and we can connect. We have not met a system we cannot integrate to, and it's completely self-contained, which I think is the biggest thing. There's no towers involved.
Well, you're the perfect person to do this work, Savannah, just given your underwater, background with the Navy and then your ground background with iRobot and, everything else. So great to meet you. So great to have you on this podcast. I'm so excited we got to actually do this. And I do want to just tell everybody also before we dial it off, two quick things. Number one, Clubhouse tomorrow, we have next week's podcast guest on. It's going to be Michael Cohen, CEO of QII AI. They're doing incredible things with artificial intelligence and machine vision for inspections. So please be sure to check them out. They're actually going to be on our Clubhouse tomorrow as well. So Drone Law Connections tomorrow, which is at 11 a.m. Mountain, 1 p.m. Eastern. You think I'd have this down by now. Michael will be on there. And Michael and QII are part of a larger Carahsoft partner series. Carahsoft is one of the leading B2B IT resale outfits in the country focused on government IT solutions. So especially at the state, local, travel, territorial levels. All right. So by the way, Savanna, one of the groups I introduced you to, the Advanced Mobility Collective, are up on the net. They say, we love all of this. They are going to absolutely love you. I can't wait till you talk to them. And Dan Julian once again says, thanks so much today. Glad I was able to catch this one. So thank you, Savanna. Thank you, Dave Peterson, CEO, that helped make this happen. Thank you, Fenix Group, for sponsoring today's episode. And of course, Dragonfly for sponsoring the whole month. That's all she wrote, and we are out here.